Section 6.3 is changing a fraction to a percent and a percent to a fraction. No new vocabulary is introduced in this section. We've already done this a little bit where we set up a fraction and we created a percent. Remember, percents always go over 100. So in this particular one, we already have it over 100, so it just simply converts straight across and it becomes a percent. Very straightforward. So if it's already a fraction, we put it over 100, and the top number then automatically can be considered a percent. So again, if it's not 100 on the bottom, what do we do in order to create it to be 100? Well, we can do it a couple of ways. Remember, we can cross multiply and divide. Certainly works. Some of these that we can see also that what do we do to the top, do to the bottom? What do they do to 20 to get to 100? They times it by 5. So if we multiply the bottom by 5, we multiply the top by 5, and then we have 85. And then once it's over 100, it's a percent. Okay? Problem number 9. Not the same problem. I'm not quite sure why that's there. It fooled me. So let's change that. Let's make this 47 over 20. Okay, still got to go over 100. So what times 20 again? Let's do it the other way. Let's do it the cross multiply and divide method, just to remind us how we're going to do that. So we're going to have 100 times 47. So 100 times 47 equals 4,700. We're going to divide by 20 equals 235. And as soon as it's over 100, it's a percent. Okay. What if it's a mixed number? Well, we have to again put it in fraction form. So let's make it an improper fraction. So 4 times 5 is going to give us 20, plus 3 gives us 23 fifths. Remember, we have 4 groups of 5 plus the remainder to make it an improper fraction. But then the rules aren't going to change any. It's still got to go over 100. So we can either cross multiply or divide, or how many times will 5 go into 100? We'll go 20 times. Do it to the bottom, do it to the top. So we have 460%. So once it's over 100, that's our answer. So again, I would multiply the base times our whole number. So 4 times 6 is 24, plus 1 is 25. That's over 4. Percents are always over 100. You're going to repeat things a lot just so it'll go into long-term memory. So let's do it on the calculator here. So we have 100 times 25 equals 2,500 divided by 4. 625. And once it's over 100, it's a percent. Okay? So not everything is going to go in nice and easy. So when we get down to problem number 25, they're going to tell us it's okay to round to the nearest tenth of a percent in our answer. So let's go ahead and use, since 13 doesn't go into 100 very easily, let's just cross multiply and divide. So we have 8 times 100 equals 800 divided by 13 equals, I'm going to write it up here, 61,538,461, da 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 da. All right, it says we can go ahead and round to the nearest tenth of a percent, because percents are over 100, so this is a percent at this point. So we're going to round that. Here's the tenth. We take this one and the one to the right, so 53 is going to round down. Okay, everything behind goes to zeros. We don't have to write it. Everything in front stays the same. And we've rounded that to the nearest tenth of a percent. So just the opposite then is true. If we have percents, now they want us to make it fraction. Well, as we've said before, percents go over 100. So 12% then is going to go over 100. We can drop the percent at that point and put it into fraction form, and then we can reduce or simplify. 4 goes into both 100 and 12, so if we divide the top by 4, we can divide the bottom by 4, and we get 3/25 in its simplified form. So percents go over 100. Problem number 37. At that point then, the percent sign can go away, and now we're reducing. Well, we have an improper fraction. How many hundreds in 130? 1. Leftovers then are 30 hundredths, which can be reduced by 10. So we have 1 then and 3 tenths. Percents go over 100. Sign goes away. We can reduce. So they're both even. That'll give us then, we can divide by what? 4. 4 will go into both. We could do 2, but 4 is bigger, so let's go ahead and just do it by 4. And we'll have 21 25ths. And that's simplified. If we did it by 2, we would have then 42 over 50, and we would have to reduce again. So that's why I picked 4. Well, here's kind of a funny one, and this is why I picked this one. Percents go over 100. Okay, and once we do that, but we cannot have decimal fractions. That's against the rules. So we have to convert this. So our conversion is that we need to make this a whole number. And we can make this a whole number by moving the decimal 1 spot to the right. Well, if I do it to the top, I have to, do it to the bottom. Okay, so the decimal was here, moves it over here. So this now is 455 over 1,000, because we had to fill in that spot when we moved. Now we're going to go ahead and reduce. Well, we know that 5 goes into both of these because they're both 5 and 0. So let's go ahead and do that. Divide each side by 5, or the top and the bottom by 5. 5s and 45 is 9. 5s and 5 is 1. And 5s and 10 is 2. Plus the 2 zeros gives us 91 over 200. Okay, so whenever we have a decimal percent, percents go over 100. Perfect, just like what we've always done. But we got a rule problem. Cannot have decimal fractions. So I have to move it over to make it a whole number. If I do it to the top, I do it to the bottom. Let's do another one of those. Okay, so we would have 24.4. That's going to go over 100. But remember, I can't have a decimal fraction, so I've got to make this a whole number by clearing this out by moving it to one spot. I do it to the top, do it to the bottom, add my 0. So now I have 244 over 1,000, and then I need to reduce that. So we notice that probably 4 will go into both of those. So 4 into 24 is going to be 6. 4 into 4 is 1. 4 into 100 is going to be 25. If I add the 0, gives us 250. And we are reduced. 61's prime. Okay, this one's even a little bit more tricky because it is a fraction percent. So we can do it a couple of ways. We can make this a decimal. So let's do it that way first. So let's go 2.5, because a half is 5 tenths, and then that's a percent. Percents will go over 100. Then we have to clear it out by moving it over 1. Move that top over 1, move the bottom over 1. I now have 25 over 1,000. Okay, how many 25s and 25? 1. So I can divide each one by 25. And how many 25s in 100? 4. And then the 0 drops over. So that becomes 1/40. Okay, another way to do this is we make it an improper fraction. 2 times 2 is 4, plus 1 is 5. So I have 5 halves over 100. Okay, this is, I think, the harder way, but it is a way that some people have learned, so I wanted to show it to you. Okay, so now this means that this is 5 halves divided by 100. So what we would do then is we're going to have 5 halves. We're going to divide by 100. 100 over 1. Remember, we flip and multiply. Okay, so this then becomes 5 halves times 1 over 100. So any number on the top reduces with any number on the bottom, remember? So how many 5s in 5? 1. How many 5s in 100? 20. So 1 times 1 is 1. 2 times 20 is 40. And the answer is the answer, just depending on how you want to get there. Either way is perfectly acceptable. Either method is just fine. Whatever works for you or you've learned in the past and this is a refresher for, that's perfectly fine. Good luck with the homework.